limited computing capacity, because what they would like to do is access our resources. So they are interested in the computing capacity via which are available through a portal like the Science Software on Demand or EC3 portal or gateways to do some analysis, collect the result, and produce some application as well. So we have this custom setup. We have a dedicated virtual organization to address the requirement of this topology types of user. And after 6 months of support, what we usually do is try to discuss together with the customer if they want to move forward. So if they want to, for example, continue this interaction with EGI services, but maybe they need more additional capacity. So we move them in a more community allocation setup. Or if they are not interested, maybe they can just exit because of the capacity we provided were enough to produce their simulation, produce the expected result, and that's all. So we have a dedicated setup for long tail of science user, and also advanced setup, let's say, with more capacity for community organizing and structure virtual organization. So in this section, I will briefly introduce the following list of data analytics services. I will start with EGI Notebook services. I will introduce the EGI Workload Manager to perform a computing workflow in a distributed environment. I will introduce the Elastic Cloud Computing Cluster developed with the context of the Indigo Data Cloud project. I will introduce the Science Software on Demand, which will be soon be available in the marketplace. This is an evolution of the Catania Science Gateway portal developed by NFN. And I will finish with introducing the EGI VMOps dashboard, which allow users to deploy a virtual machine on a different VMs topology on the EGI for the cloud infrastructure, and the CHIPSTER. This is an activity that we start in collaboration with the CSC. So CHIPSTER is basically a framework, a software that can help biologists to perform a next generation sequencing of data. Of course, the 25 minutes are not enough to go too much in details. This is why after the coffee break, we have 2 coffee breaks today. Starting from 3:30, we have a clinic section. We have 3 parallel sections where in more details, the service developer will briefly provide additional information. And if you want, you can raise your comment and question directly to Enol for the notebooks, Miguel and Amanda for the Elastic Cloud Computing Cluster. There is Alessandros Nakos from IASA for the EGI VMOps dashboard. Ricardo for the Science Software on Demand, Kimmo for CHIPSTER, and Andrei for the Workload Manager. Okay, so let's start with the first in the list. So the notebooks. I hope you are quite familiar with what Jupyter Notebook is. So a notebook, in a very nutshell, is an open source solution which offers the possibility to combine software, data set, and test to perform some specific analysis. The software can be written in different languages. There are different kernels available. The most common one is Python, but you can easily customize your notebooks in order to support different languages such as R, Octave, Julia, and many, many others. So this is just an example of notebooks that we prepared, for example, to support a pilot activity in the context of a PANOSC project. Through this notebook, basically the most advanced characteristic of this notebook is the possibility that you can share this notebook with others working on the same experiment, let's say. And this is the reasons why the notebooks are the perfect solution adopted in data and software carpentry events. So the EGI Notebooks is basically built on top of Jupyter Apps. So we are not reinventing the wheel. So the services that we are offering and which is available in our service catalog is basically based on this technology. But what we did is to include additional customization, because by default, the Jupyter Notebooks support local accounts. So before to start your notebook, you need to be authorized, authenticated. But what we need to do is, what we wanted to do is to extend this to our federation members. So we extended the authorization framework in order to support a federated authentication mechanism using EGI check-in services. We also want to offer the possibility to use a persistent storage. So every time a notebook is created, the user has a dedicated space where they can keep the files, the notebooks, and if you close your section, the data will still remain in the notebooks. And of course, we want to offer these notebooks to our end users. So this is why we leverage on the computing and storage capacity offered by our provider for offering these services to our users. So the services is offered in different, let's say, service models. The official one, you can see here the URL is the services which is now in production since the end of 2019. The service is open to anyone. So if you have, you can access using EGI check-in services. As soon as you generate your EGI personal account, you can access and spawn notebooks using our capacity. Since it is open to anyone, we have a limited capacity. So we offer for each notebook, the user has 1 CPU, 1 GB of RAM, and 10 GB of persistent storage. But this is a configuration setting. We can increase this resource capacity on demand. For example, in case there is particular event requesting additional capacity, this can be easily done. In case of inactivity, the notebooks will be automatically killed after 1 hour. So this is just to avoid that the capacity will be completely full. So if you want, you can download your result even if there is the percent storage capacity. So this is a possibility. So we have this custom setup which is open, for example, to target the requirements of the long tail science user. There is a dedicated instance also for training activities. So we have a notebook configured for running training events. And we have also some custom setup for supporting the characteristic technical requirement of community. So what we did in the past is to cooperate in the project, also to work with the community in order to set up EGI notebooks for to address the requirement of different scientific communities. For example, in PANOSC, this is what we are doing. We had a dedicated setup. The only difference with the EGI notebooks is that the authentication is based on umbrella ID instead of EGI check-in. But the requirement of the customization, this can be discussed together with the community. Today, during the presentation, there is D4Science will report their experience in using the EGI notebooks in the context of the AGINFRA project and other initiatives. And again, there is this clinic section. So if you want to get more information about the services and interact with Inol Fernandez from EGI, please don't forget the clinic section starting at 3:30, and this is the room to connect and get access. The password is, of course, the same. So another analytics services that we are trying to promote as much as possible is the EGI Workload Manager. This is based on Dirac, which offers functionality to federate the different computing infrastructure. Originally, this framework was provided to support multi-experiments such as from AIP, so from the high energy physics community, but now this is also used in a different context and a different community, including biologists, structural biology. There is also community from earth science, and today WeNMR from ASCAT will report their experience in using these services. Dirac allowed to access distributed computing infrastructure that can be federated through this framework. You can submit workflow, so intensive simulation on both grid and cloud resources. It also provides functionality to interact with the data, so you can basically manage simulation requesting access to data. The output can also be uploaded on a different storage element. There are different backend are supported. You can easily interact with the Dirac using the traditional command line tools if you like to work with a CLI, but there is also a web interface like the one that you can see here, and there is also possibility to use a REST API based on Python. And recently, Andrei is working in order to integrate Dirac with the Jupyter Notebooks. So there is still a prototype, and soon this functionality will be available. Of course, there are some additional customization that are available for specific requests and needs of a different community. More details, again, will be provided by Andrei today in the clinic section. I would like also to inform you that EGI organized a webinar just a couple of weeks ago. In case you missed this webinar, the information, the material are available online. I just put here the link. There is also available the recording. If you are interested to use this setup for supporting your community, you can have a look to the material, and you can also interact with Andrei afterwards. Now, the next list is EC3, the Elastic Cloud Computing Cluster. This is a solution developed by University of Valencia in the context of the Indigo Data Cloud project, and now it's also supported by IOSC. We started this collaboration with UPV many years ago now. What we did together is to create a custom setup of this framework to target the requirement of the long tail user. So the framework offers you the possibility to deploy on demand an elastic cluster on a different public and the private providers, cloud providers. You can see here some example. There are different plugins available to deploy the cluster on Amazon Web Services, Google Cloud, Azure, but also OpenNebula, OpenStack, and many others. In the past, for example, we worked together with in the context of Elite's HNSI Cloud project. So we created a custom dedicated plugins to deploy the Elastic cluster on T-System and the RIA groups and commercial providers. So the fundamental characteristics of EC3 are reported in this slide. It's basically rely on infrastructure manager, which is the component that physically deploy the cluster on the selected cloud provider. There is clues, which basically is responsible to operate the cluster. So it can spawn a new nodes of the cluster on the fly if needed. For example, if you need to to start a simulation requesting a lot of computing nodes, clues will, first of all, on a regular basis, we'll check the status of the cluster size. If necessary, it will start a new nodes of the cluster before to start your analysis. The nodes of the cluster will be powered off automatically in case of inactivity, of course. And the last important component is represented by Ansible, because the cluster can be configured via Ansible. There are different recipes available because you can configure your cluster selecting one specific local resource manager. If you are familiar with the typical grid cluster, you have the same similarities. There are different recipes available to configure a cluster with Kubernetes, Mesos, Slurm, Torque, and also to configure your cluster with additional application. So yesterday, for example, there was in the data management data workshop, there was the report from Ophidia. Ophidia basically created an Ansible recipe to deploy an Ophidia cluster with the EC3 on the EGI Fed Cloud infrastructure. So also in this case, EGI organized already 2 interesting webinars to introduce infrastructure manager and the Elastic Cloud Computing clusters. So if you are interested, you can have a look to the material available online. I will briefly show you the web interface, because there is also available a command line tools and some API that you can use to interact with EC3. The service is available on the marketplace. So in principle, you can select, you can submit a service order, and when approved, you can access the portal and deploy the services, the cluster on one of the available providers supporting the access view. So as I said before, I will briefly introduce you the wizard, which is available to drive the user through the different steps. In a few clicks, you can select the characteristic, the topology of the cluster that you want to deploy, to run on the cloud. First of all, you select the local resource manager. As I said before, you have different options here: Torque, Slurm, Kubernetes, etc. All of them are available. You can select additional software packages that via Ansible can be deployed on the fly on the cluster. If you want, you can also create your Ansible recipe. So you can work together with the developers to add on this list an additional application. I did in the past for NAMD. So I worked together with Miguel and Amanda, and I worked on this Ansible recipe, which is now available in the portal. So in the second step, you select the endpoint. So this is one of the available providers of the federation where you can deploy your cluster. You can select the front end and the working node instance type. And the last step, you select the maximum number of the maximum size of the cluster. So in this case, 2, and you can put a label to identify the name of the cluster. And once this cluster is ready, you will be able to access the front node of the cluster via SSH. The key will be automatically generated by EC3 portal. So you can download this key and you can SSH on the front node, and from the front node you can deploy application because the user is in the sudos list. You can also run simulation with available software selected that you already configured, etc. For more details, please don't forget to join the cleaning section in the room number 4, where Amanda and Miguel will wait for you. Another service analytics that I want to introduce now is the Science Software on Demand, developed by NFN. This is basically a general purpose gateway built on top of the future gateway framework developed in the context of the Indigo Data Cloud project. So the portal is based on LifeRay 7.1 with the for the authentication. So customize the module for supporting to enable LifeRay to support OpenID Connect protocols. They already integrated with EGI Check-in and the YAM from Indigo. They have already some pre-configured software and application. And also in this case, the INFN is offering this portal. So in principle, you can also interact with the main developers if you want to add a new portal in the Science Software on Demand gateway, or if you want, you can also interact with the developers to have a custom instance of this portal for your community. Ricardo is waiting for you in Zoom number 5 to answer your possible comment and question if you need some specific support. The EGI VMOps dashboard, I think it's one of the solutions which is now available since a couple of years. The overall goal of this dashboard is to offer the possibility to deploy VM's topology on a different infrastructure. So far, the topology are deployed on a single cloud provider, so there is no possibility to have a hybrid topology where virtual machines are started on a different providers. Also in this case, there is a wizard-like interface that helps the user to select the characteristic of the VM topology to be deployed in the cluster, and you can also customize the VM's topology performing, for example, running some specific script on a boot at the boot time. It offers possibility in case of troubleshooting to contact directly the administrator, and you can also have a global picture about the cloud provider availability, just to prevent to deploy topology on a provider with problems. We are scheduling a webinar in a couple of weeks, so Alexander will introduce the last feature of the VMOps dashboard. So if you're interested, you can register and you can attend the webinar, which is scheduled the 25th of November. And today, you will wait for you in Zoom number 5 for comment and question. Okay, the last data analytics services I would like to introduce is CHIPSTER. This is a user-friendly analysis software for biologists, basically. This is a software developed by CLC in Finland. We started this collaboration 5 years ago, I think, probably more. So what we have done recently is we have a custom setup in EGI infrastructure for the long tail of science users. So what we did recently is to extend this software in order to support federated authentication mechanism. Everything will be now available via web interface. In the first version, you need to download a Java file and you need to start from your machine. This was prone of several problems due to the Java license, but this issue has been solved now. There is a web interface from where you can run your analysis. The code is completely open source. If you want to, you can have also a custom installation for your community. All the information available on GitHub. There is also a lot of training and documentation available online. And also in this case, we are going to organize a webinar where the last feature will be introduced by Kimmo, Petri, and Eija from CSC. So also in this case, the webinar is available online. So if you want, you can register. The registration is free. And today, Timo will wait for you in Zoom number 5 for a comment and question. And okay, this is my last slide with some pointers. If you're interested to get more information about the data analytics services that I mentioned before, but as I said before, I kindly invite you to attend the clinic section if you want to get in touch with the service provider and discuss with them a possible cooperation, or if you already are user of these services, if you have any comments or problems that you want to discuss directly with the developers. So thank you for your attention. I think now we can move to the next speaker. Andrea, are you going to share your screen?
Yep. 1 second.
Okay. Thank you.
Okay, can you see my screen?
Yes, yes, we can.
Okay, so we're going to describe a little bit the community deployment of AGI Notebooks that we have done for D4Science. Pasquale Pagano, that is the technical director of D4Science, is also in the chat, in the meeting. So, you know, if you have questions also specific for D4Science, you can also reply. So what is D4Science in brief? It's an infrastructure which enables virtual research environments. The virtual research environments are web-based, community-oriented, comprehensive, flexible, and secure working environments, which are conceived to serve the needs of a designated community. They can be dynamically created with little or no cost for research providers. And they support all the phase of research lifecycle and the research process. Currently, D4Science is managing it's more or less 150 virtual research environments, which are available through using 19 gateways, and they serve more than 30,000 users. The deployment that has been done for the D4Science community of the EGI Notebooks, this is one of the options that you know, Giuseppe previously mentioned of the deployment. So we have the catch-all notebooks and the custom deployment for the specific communities, and D4Science is one of them. So first of all, we have set up OLA with the AGI cloud providers in order to host the resources, and we also have SLA that has been recently extended in order to include the notebook service, which includes also the the parameters for the SLA, for reliability and for the service. The projects that are benefiting for the deployments of the EGI notebooks for D4Science are 3: AGINFRA, BlueCloud, and SoBigData++, where also AGI is a member. This is the diagram of the deployment that has been done for D4Science. So on the right there is the usual deployment that we do for the notebooks. So basically deploying Kubernetes on top of AGI cloud providers. And then there has been like some customization for the specific needs of D4Science. So basically the hub, so the authentication for the users is connected with the D4Science profile API specific for them. And then each user pod, so it's a notebook that is created for each user, is connected directly with the user workspace. It is a D4Science feature, is a workspace that is available for each user. Then I will give you more details about this. So describing a little bit in detail what are the customization that's been done for notebooks. So for the authentication, there is the integration with the authentication authorization framework for D4Science. So in order to do this, a new Jupyter Hub Authenticator class has been created, which takes the user personal token from a virtual research environment, and it uses this to get the account the user account details. And so I put the link here on the framework that has been implemented in D4Science for this. And there is also a customization of the spawner for the Jupyter Hub. So basically, there is a possibility to, so user have the possibility to select different flavors of the notebooks they would like to run, and this is specific for this particular deployment. There is also one of the characteristics of the virtual research environment, of course, is that everything is embedded in a frame. So basically, we can the users can have access from the Jupyter Hub and Jupyter Hub and the Jupyter Lab directly from the same environment where they have all the different tools that they're using within the virtual research environment. And then, as I said before, we have integrated also the workspace. So each virtual research environments in D4Science have an associated workspace for users. They can be used to share files and among the different participants for the virtual research environment. This in particular has been implemented using Fuse-based mounting system, which relies on the library, the storage app library in D4Science. Technically, this is done with the sidecar container, which is of the user notebook bot, and is made available under the workspace home of the pod of the notebook. Basically, you can you can see from here you can browse the workspace of D4Science within the Jupyter Lab notebook associated to each user. Other customization. So the notebooks environment includes tailored libraries for D4Science users. So they have the possibility to ask for to include in the images libraries that are needed, for their specific activities, and having the possibility also to have tokens that are coming from the system within the notebook environment. So they're allowed also to call other services within the D4Science infrastructure, for instance, data miner, which is one of the services that are available inside the D4Science using the WPS interface. So as I said, one of the projects that where we have developed the notebooks is AGINFRA. This is the first project where the AGI Notebooks integration has been piloted. So all the different integration that I've shown before has been performed initially in the context of this project. At the moment, the resources that are used for the particular deployment are shared with the notebooks catch-all instance. So we are supporting 559 users from 11 VREs. And there are also other extensions for the notebooks, for instance, and the notebook viewer for notebook rendering. The other deployment that has been performed is for the BlueCloud and SoBigData++. So this is particular deployment because it's not hosted in AGI Cloud resources, but on one of the sites that are they're forming the D4Science infrastructure, in particular in Italy. So basically, even though the resources are not part from AGI, the deployment and the operation of the services performed by AGI is part of the SLA that we have set up with the D4Science. The current capacity of the cluster is for 80 users concurrent with the AGI for the per notebook, and the active users for the two project, so the ones that are actively using the services are support 23 for BlueCloud and 17 for the SoBigData++. So just to show that what are the plans for this deployment. So we have some announcements on the line. So related to component, the user support and the operations. So for instance, we would like to streamline the installation of library notebooks. So because now if users, they want to install. So either they can install, every time they log in into the system and new notebooks start up, they can install the libraries that they need, or they can open a ticket to the support, and which is redirected to us to include the libraries that they need inside the base image for the notebook. So they will have every time they log in the library that they need. But this is quite time consuming, because of course every time you have to open a support ticket, so it's not like straightforward. So we're trying to understand if it's possible to have like a better way to let user upload their images, for instance, using CMFS for distribution. This is something that is under testing. Or we have to include, for instance, information at runtime of the notebooks type, so CPU, memory, and monitoring, which is done, it is to be deployed. And for the operation, we still have to perform the backup of the NFS for this data that are where the user data are stored. And on the plans, for next year will be also the publication of the notebooks to the D4Science catalog, which is one of the components of the D4Science ecosystem. And this is something that will allow also sharing notebooks between users. Just last lines, just to show what are the kernels that are supported for D4Science. So we have the default Python 3 kernel, which include the commonly used data analysis machine learning libraries, which is coming from the SciPy notebook, Julia programming language, R for which several packages from the R ecosystem, and Octave also, which is as its own Conda environment. Okay, thanks. This was for the description of the D4Science installation.
Thank you, Andrea. I think we can move. We are perfectly on time. We can move to the last speaker, EGMR from ESCAT, to report their experience in using EGI Workload Manager. And after that, we can open the Q&A section. So if you have any comment or question, please, you can raise your hands. You can post your question directly. Okay, see, Ingemar, you are okay. You are sharing your screen.
Do you see the presentation or?
Yes, I see your presentation, but you are not in presentation mode.
Oh, I don't know that. How can I fix this? Is this okay anyhow, maybe? Or is it too small then?
Or maybe you can go in presentation mode and then you can share your screen with Zoom. Probably this trick.
Maybe, yes, maybe. Yeah, okay, I will try that. Close. How do I get? I don't get the. I cannot get the Zoom back. It's there. Okay. So first into presentation, but then I can share the full screen, or can I?
Otherwise, I can share for
Starts
you.
From the, no, I went into this again. I'm so sorry.
Oh, it's okay, no problem.
If I just make it big then. Is this okay then, or?
Well, I don't know for the other slide. I can see quite clear your first one.
Yes, and okay, so I will talk some about the iSCID 3D analytics for that we have been working in EGI here. And that is myself, and also Carl Fredrik is also on the call, I see. And so we work at ISCET Scientific Association in Kiruna, Sweden. I will describe, so ISCET 3D is a new research radar that we are building up in the Northern Europe. It consists of 3 sites, each looking like this, about 10,000 antennas of each. And we started building last year. And we are supposed, it should be ready about 2022, I think. So it's in 2 years. So far we have just this little one in the corner here, so that we are testing receiving and transmitting capabilities. So which is only one little part of this big antenna then. Yes, this is a map where we are situated. We are in the far north, as I said, in the northern Scandinavia. So we have 3 sites currently. Each of them, or we are planning 3 sites, and we will have very high-speed data links between these sites. And so we will have terabit links, and we expect to collect all the data into the Norwegian site here in Skibotn, which is the central, the core sites really, where we have the transmitters and also that most of the computing software then and hardware. ISCET 3D data. Yes, so we have been looking at quite a lot of the techniques for how to handle the data then. So and here you see quite a lot of acronyms that we have been investigating. And we have started to work on this Dirac manager then. So as you can see, most of these things are centered on Dirac then. So we have the web interface, we have the catalog, and we have the storage elements which are in the archive, which is within the ISCET premises then, so to speak. We are using a check-in for the authentication of users, and we are planning with the Dirac manager, we will manage user analysis and other type of analysis, and these should then be put into the B2 family. So we have been looking at the B2 share repository, and then also connect Dirac to the B2 find then. So this is the plan actually, but we have not implemented everything, but we have tested parts of these separately at least. Yes, so we need this authentication part just because we have different levels of data, and each level depends a little of who is taking the data, who is the PI of that experiment, and so we have the lower level is actually rather sensitive because we can see things that you are not supposed to see. We see quite a lot of satellites which are secret, and so the lowest level are closed data that we just within ISCET. But as you reduce data, you also reduce we can open up part of the data. So we have the level 2 data, which is the spectral data that is embargoed according to the members, how the association is set up. And so each member will have his own data for some time until it's open to the whole association, and eventually also to the whole world. And the higher level is the level 3, where it's open data, and which is just the analysis parameters. And so we focus on the ionosphere, but we also have atmosphere, meteors, space debris. And to handle all these type of data, then we need quite good authentication and also for the management of the data. So we have this competence center that we've been working with within NEOS Hub, where we've been looking at the Dirac interware as an integration component and as a web interface for users. And so here is a little example how the file catalog works, and you have some part of the metadata that we have been extracted of these. So we can search in these data according to this metadata, or you can also specify just one experiment here like this. And we have been looking at the EU.DATS B2 services, and also the authentication, as I said, for the access control. The direct file catalog is currently just based on this level 1 and level 2 data that we have. And all the files are, all the data storage is at iSCED currently. And that is a thing that will continue even with when iSCED 3D comes along, I think, at least the lowest levels and so. But they are searchable because all the metadata is there. As I said, we hope to have B2 share entries, but so far we haven't have a way to interact between Dirac and B2 Find here. So that is the thing that is still lacking. We have been working at EGI Check-in, as I said, and we have the job submission is we have a cloud in CSC that we have Docker that so from the Dirac we can submit jobs to this Docker then, and we have deployed some software, and it's controlled by this normal sandbox. That's as you see, there are some inputs and you have the output. This is just some example of these user analysis that we are expecting then. So far we have the general tool for display, which is part of that we have implemented, which is a rather simple setup. It's written in Octave and is partly also in C. It is display. It contains display and also some sort of analysis you can do. So we are reducing level 2 data for users within that, and then into more easily handled data than for users to run their own analysis on. EGI Check-in, yes. So the access is then controlled by the EGI Check-in. We have set up a virtual VO for iSCED. Currently, I think it's not implemented yet, or maybe it is. But the iSCED VO will have no management, so everyone can connect, can be a member of the iSCED VO then. And as long as you are a member of the iSCED VO, you can access all the open data that are available then. If you want to access restricted data, you have to be in a group. And so we have set up a number of members where each of our members is one group. So I don't know if you can see the groups here, but we have the groups are according to countries, depending on type of member. So the top one here is China. So if you are a scientist in China, you're allowed to access all Chinese data that are not belong to China, but they are marked by China then. And we have also other uses like the smaller affiliates, which is just institutes. But the management of these groups is done by the members themselves. So when we get the member, they have to set up a VU manager for that group. And with that, EISCET itself doesn't need to do this kind of management, which is we have currently about 100 users that are really accessing data as such, but for the higher levels of data, which is more or less this open part, and we have about 1,000 users all over the globe. Then we have also been implementing the Jupyter using the EGI Notebooks, where we implement the same software that we have for the job submissions. So we expect to use these notebooks for the users to develop their own analysis, and then they can use that software into the batch submission that we have for the Dirac then. So it's based on this RTG, which is the real-time graphs, which is normally run via a GUI. But here in this Jupyter lab, it's only via the script. So we have been needed to, or we have been forced to rewrite some functions to control this, the software, how to run it and so on. So we have most of these things are now text-based routines that you can call and so on. Which is not what we at least we have not solved yet, is to integrate this directly with Dirac. So the data should come directly into the notebook from Dirac, and we expect to have that soon, I think, at least. And also to start up this RTD toolbox within Jupyter Lab is not really solved yet. Of course, so there are some extra commands you have to do to get everything into the paths and so. And we need also some documentation for this, for this user script, I think. So I think that was the last one. Yes, I can see that on the left here. Thank you.
Thank you, Ingemar. About your last slide, this integration of the Jupyter and Dirac. I think that this integration is almost done, because I remember that Andre, during the webinar that we organized a couple of weeks ago, said that the prototype is almost ready. There were very minor issues to be solved before to make this integration, this feature available. So
yes.
Maybe you can connect to the parallel section, clinic section, where Andre will report more about Dirac and ask directly the status of this integration, because I think it's quite useful for you.
Yes. Okay. Yeah. Yes. Certainly. Yes. We have been working quite a lot with Dirac, but it's it is mainly on this access and also the metadata harvesting and so that. But and in parallel, we have been doing this Jupyter, but we have just been waiting for the integration. Yes. Yeah. So we haven't really have some pressure on Andre yet on that. But
I think that well, by the end of this year, for sure, this work should be done. But you need to double check with Andre for sure.
Okay. Good. Fine.
Okay. So we have now 50 minutes for the Q&A section. I see there are a lot of technology providers connected. So if you want, you can also post your question directly in the chat, or if you want, we can mute all of you, so you can enable your mic and ask directly. So please. Any comments, any question about the technology, the solution that we presented? Do you want to ask more clarification?
Sorry, can I make a, sorry, just to reply to the comment that is here about the access to data from the inside the notebooks. Just to confirm that, you know, when you enter the AGI notebooks, and you authenticate with the check-in, you will have an access token directly on the environment. So then you can use it to access, you know, a service which are behind check-in. So this is how it is possible to implement it. This comment from Carl Frederick.
Yeah, sorry, I didn't see the chat. Thank you, Andrea. I don't see any comment or other question. Anyway, I hope that this introduction, this section was quite useful for you to have a general understanding about the status of the service that we are offering. As I said before, maybe I can share again my screen with the different clinic section. So we are going to have 3 parallel sections starting from 3:30. Of course, okay, probably in the first one, the chair will be an all. Gianni will be the chair of the second clinic section, and no, sorry, I will be the chair of the second clinic section, and Gianni, our colleagues from EGI will coordinate the activities on the workload manager section with Andrea. You see here the different room to access. So I invite you to join this session and get in touch, directly with the service provider. I cannot see the chat now. I don't know if there are other comments. No. Okay. If not, I think we can close the section. So thank you all of you for joining this session dedicated to EGI Data Analytics. Thank you for the speakers. And I hope it was useful again, and see you in the next section after the break. Have a good afternoon, everyone.